Good morning, class. It's Miss Carr. I'm actually in our classroom this morning without you guys. It's really sad to be here. Hopefully we can all come back on the 8th and that we'll be able to, be in person again and stuff, because it's really lonely here without you guys. So I miss you guys a lot. But today I thought that I'd do some of our lesson, where you can see me instead of just like on the iPad. And so today we're going to actually be talking more about fusion and fission, and we're going to be talking about how we can see those things in the world around us, examples of it. And so remember, fission is when there's a unstable, large nucleus, and then it breaks apart into two smaller ones. And then fusion is kind of like the word fuse, so it's when we have the two smaller nuclei that come together and form a nucleus. Okay, so let's look at our first example. So this one is saying, how do atomic and nuclear bombs work? Okay, we kind of watched a video at the beginning of class to start off this topic of nuclear chemistry, and we talked about nuclear bombs are kind of one of the first things we think of. And so here I drew a nuclear bomb. I know it's not great, but this is a nuclear bomb. And there's lots of different ways how this could work, but one of the ways that it works, and probably the easiest one for us to understand, is that we start down here, and this is an unstable nucleus. And usually there would be a few of these. And then what's going to happen is we're going to shoot a particle at it. And when we shoot the particle at it, it causes it to break apart into two different nuclei. And then this reaction can actually continue to happen. These can break apart and these can break apart, and it will continue to break apart. And every time this breaks apart, we actually see a lot of energy that is released. And this energy that is released is what causes that huge explosion that we see. And so think to yourself right now, like, what causes our nuclear bombs to work? Is it fusion, the coming together of two smaller nucleus, or fission when a big nucleus breaks apart? All right, hopefully you're able to answer that question. It's fission, right? We're seeing this big nucleus and then it's breaking apart into smaller ones. And as that happens, we release a lot of energy and we get a big explosion. All right, so nuclear or atomic bombs are usually done with fission. All right, let's look at our next one. So the next one that I have for you guys is talking about how does the sun get its energy. So we know the sun, it keeps like burning and burning and burning, and so we want to talk about how it gets so much energy to let off so much light and heat and things like that. And so the sun is actually going to be able to help fusion reactions occur on it. All right, let's think about our fusion reactions really fast. So in fusion, remember, we're having two nuclei come together. And if you remember, the charge of a nucleus is positive, right? Because it's just made of protons and neutrons. So we're trying to make these two come together. But do positives and positives like each other? No, they don't. So they usually don't like to stick together. But if we think about our sun is so big, it has lots of gravity. Even the Earth is drawn to the sun because of how much gravity it has. And how big it is. And the sun is also so hot, right? So because it's so hot and because it has so much gravity, it's able to pull these two positives together and make them stick. And so on the sun, when it pulls these two particles together to make one particle, when it does that, we let off a lot of energy. Okay, a lot of energy, and this energy that we let off is what keeps our sun going, what keeps light and heat and things like that. And so think to yourself, what keeps our sun going? We're having two come together to form one. So remember, that is going to be fusion. Okay, so sun is with fusion. All right, the final thing that we're going to talk about is how are elements formed. And so we talked about fusion, right? The coming together of two. And we talked about how that happens on the sun. So elements are actually going to be formed on our sun. Because again, we're going to have so much light and heat that it's going to be able to cause two different nuclei to come together to form one. Okay, so on the sun or other stars, there's we can see our elements form and they can fuse together and they become different elements. Because remember, if we have two come together, they combine their number of protons, and the number of protons tells us what element it is. If we have two smaller protons coming together, it creates a large element. And so the sun and other stars are really important for forming our elements. They form them during their life cycle, and then we also, in earth science, we learn about how suns die and things, and when stars and suns, when they die, it also creates more heavier elements that we can see. And so think to yourself again, how are elements formed? If they're formed on the sun, remember it's super hot and lots of pressure, so it's able to cause two to come together. So when two things come together, that's going to be fusion. All right, hopefully these are some cool examples to show you guys how fusion and fission, how we can see those in our lives. I think the important takeaways is that fission and fusion both release a lot of energy, and that also fusion, especially fusion, it's important that it's a really hot temperature so that we can have these two positives come together. All right, let me know if you have any questions. Hopefully I see you guys on our Zoom meeting, and good luck doing your work and doing your quiz.